Hello, for this interactive advanced concept, I am going to be talking about nuclear chemistry. So today I'm only going to be talking about nuclear chemistry since it would be too dangerous to do any experiments with it at home. Nuclear chemistry is the wide area of chemistry that is concerned with changes in the nucleus of elements. These changes are the sources of radioactivity and nuclear power. Radioactivity is the spontaneous emission of particles or electromagnetic radiation. Therefore, all elements who have an atomic number higher than 83 are unstable and considered radioactive. A radioactive substance contains unstable nuclei and is able to naturally release energy in the process of shedding high-speed charged particles in an attempt to reach a stable state. This also means that substances that are non-radioactive will remain intact indefinitely unless they are acted upon by an external force. Basically, all substances that are unstable want to become stable, which is what causes nuclear chemistry. Nuclear binding energy is the energy that is required to break up a nucleus into its component protons and neutrons. The nuclear binding energy per nucleon makes it possible to compare the stability of all nuclei on a common basis. The nuclear binding energy per nucleon can be found by taking the nuclear binding energy and dividing it by the number of nucleons. Radioactive decay is the spontaneous breakdown of an atomic nucleus, which results in the release of energy and matter from the nucleus. The main types of radioactivity are the emission of A particles, the emission of B particles, the emission of Y rays, the emission of positrons, and electron capture. The radioactive decay series is a sequence of nuclear reactions that ultimately result in the formation of a stable isotope. Scientists can use radioactive dating to determine the age of different ancient artifacts, such as fossils or different substances, through the use of half-life decay rates in radioactive isotopes. So this is really helpful if there's, for example, a dinosaur bone or a fossil the scientist wants to figure out how old it is. They can use radioactive dating to actually discover when it was alive and how it or how different substances are being broken down through their half-lives. Nuclear power is the electricity generated by power plants that derive their heat from fission in a nuclear reactor. Almost 15% of the world's electricity is powered through the use of nuclear power. However, some issues that affect nuclear power are the safety of nuclear reactors, their cost, the disposal of radioactive waste, and a potential for the nuclear fuel to be diverted to the development of nuclear weapons. So especially all handling of nuclear power and different substances that are radioactive have to be handled in an appropriate space, such as a lab. And it really needs to be done by scientists or researchers who know what they're dealing with and how to take necessary precautions to make sure they don't injure themselves or the people around them, or an unnecessary accident that could lead to a lot of destruction. And they just have to be really careful when handling with substances that are radioactive and nuclear chemistry. Nuclear fission is the process of when a heavy nucleus with a mass number that's greater than 200 divides to form smaller nuclei of intermediate mass and one or more neutrons. Nuclear fission releases energy because the heavy nucleus is less stable than its products. Many other nuclei can be made to undergo fission, but the reaction that is best to use is between naturally occurring uranium-235 and of the artificial plutonium-239. Uranium-235 makes a nuclear chain reaction possible because uranium-235 has more neurons that are produced than are originally captured in the process. This exact property makes it possible for a nuclear chain reaction to occur. For a chain reaction to occur enough, uranium-235 must be present in the sample to capture the neutrons. Otherwise, many of the neutrons would escape and the chain reaction would not occur. In a quick amount of time, you can have an uncontrollable reaction, which is also exothermic. And during the initial stages of fission, the neutrons that are generated can induce fission in other uranium-235 nuclei, which can then produce more neutrons and so on. Nuclear fission chain reactions are possible because more neutrons are produced than are originally captured in the process, like I said before, which is what initially causes the reaction. Lastly, the critical mass of a bomb, which is the minimum mass of a fissionable material required to generate a self-sustaining nuclear chain reaction, is a huge factor on how the bomb is created. Scientists and researchers have to be, like I said before, extremely cautious when handling radioactive material, and this is why calculating half-lives is so important, because it allows them to determine when a sample of radioactive material is safe to handle. Atomic bombs can cause widespread destruction. For example, in World War II, the United States used uranium-235 as the fissionable material in the bomb dropped on Hiroshima, Japan, and they used plutonium-239 as the fissionable material in the bomb dropped over Nagasaki 3 days later, which, like I said, caused massive destruction, and the people who were affected by it and even experienced the slightest amount of radiation had such enormous health defects and problems for many years to come, which is why it's so dangerous and has to be handled very carefully. But there are some benefits for nuclear chemistry, such as when it's used in medicine. And for example, it's used in PET scans or CT scans, which can help discover illnesses or diseases and can also help doctors determine the best course of treatment for their patient. Some conditions that can be diagnosed and tested through the use of nuclear medicine are heart disease, different cancers can be discovered, and neurological disorders. So that's really helpful. So I really enjoyed learning about nuclear chemistry and how it works. It is such a broad topic. So it was really interesting to discover how many ways that it can be utilized. And as long as it is used in the right context, nuclear chemistry can be very beneficial and do a lot of good, but it can also be highly destructive. Thank you.